In this question, we are dividing both numerator and denominator by cos 10 degrees. So we get one can be replaced by one minus tan 45 tan 10 degrees. So that gives you tan A plus B, that is tan 55 degrees, right? Therefore, option D is correct. In the second sum, we have to find out the value of 1 minus t square by 1 plus t square. In place of t, we are writing tan theta by 2. So, 1 minus tan square theta by 2, 1 plus tan square theta by 2. That gives you cos 2 theta, that is cos 2 theta by 2, that gives you cos theta only. Is it clear? Therefore, option C is correct. For the third sum, as theta is lying between 0 and pi by 2, that is, theta is in the first quadrant. The sides are 1 sin theta and cos theta. So we know that sin theta and cos theta both lies between minus 1 and 1, right? But since theta is lying between 0 and pi by 2, so sin theta and cos theta lies between 0 and 1. So from here we can say that the largest side is 1. And we know that the angle opposite to the largest side is largest. Therefore, the largest angle is opposite to the side 1. Now, one interesting thing is there that sin square theta plus cos square theta, again it gives you 1 square. Yes or no? That is, we can say that it is nothing but the triangle is nothing but a right angle triangle whose hypotenuse is 1 and the measure of other two sides are sin theta and cos theta. Is it clear? Therefore, the angle opposite to the largest side is nothing but 90 degree. Is this clear or not? Therefore, option B is correct. In this question, they have given a square plus b square plus c square minus ab minus bc minus ca is 0. So that implies, if I take a half common, so 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca, which is equals to 0. That implies a square minus 2ab plus b square plus b square minus 2bc plus c square plus c square minus 2ca plus a square, that is equals to 0 implies a minus b whole square plus b minus c whole square plus c minus a whole square is equals to 0 implies a is equals to b equals to c. That is, the three sides of the triangle are equal, means it's an equilateral triangle. Therefore, angle A is angle B is angle C, which is equals to 60 degrees each. Therefore, the value of is nothing but sine square 60 degree 3 times. So that gives you 3 root 3 by 2. Thus, option C is correct. Tan theta is minus 4 by 3. We know that tan theta is negative in second and fourth quadrant. Right? So, if this angle is theta, this is 4, this is 3, so this is 5. Therefore, sin theta is either 4 by 5 or minus 4 by 5. Why? Because because we don't know where does this theta lies. It can lie in the second quadrant as well as theta can lie in the fourth quadrant. So if it lies in the second quadrant, sine is positive, so it will be 4 by 5, perpendicular by hypotenuse. And if it is in the fourth quadrant, then it will be negative, so it will be minus 4 by 5. So option B is correct. Is it clear? Tan 5 theta equals to tan 3 theta. That implies sine 5 theta by cos 5 theta. Let me cross multiply. And then taking everything in the left hand side, we are getting sine 2 theta is 0. We know that when sine theta is 0, theta is, in this case 2 theta, is n pi, where n belongs to any integer. Is it clear? So your theta is coming to n pi by 2. Now here, maximum students will do this mistake. They will tick the option B. But one thing you should consider, that when theta is n pi by 2, n belongs to any integer. Now if n takes any odd integer, look at very carefully. If n takes any odd integer, then these values will not satisfy the equation. Let us take an example. Let us say n is 1. If n is 1, then theta is pi by 2. Therefore, the equation becomes tan 5 pi by 2. Tan 5 pi by 2 is equals to tan 3 pi by 2. But in both the cases, look at very carefully. Tan 5 pi by 2 is nothing but cot 0. And cot 0 is undefined. So this equation is not valid for any odd values of n. Is it clear? Therefore, we will take, let us say that n is an even integer. Let us check in that case. Because one thing for sure, that if n is odd integer, this equation will not be satisfied. Now if n is an even integer, in that case what happens? Let us take n is 2. So in that case your theta becomes pi only. Now check whether this theta equals to pi satisfies this equation or not. Now it becomes tan 5 pi. Tan 5 pi is tan 0, which is 0, and tan 3 pi again it is tan 0, so that value is 0 again. So it is satisfying. So if you take any even values, 2, 4, 6, whatever, it will always satisfy the equation. But if you take any odd integers like 1, 3, minus 5, 5, whatever, it will not satisfy the equation. Therefore, your n is always an even integer, means your theta will be, say, 2m pi by 2, because I am replacing n by 2m, where m belongs to any integer in that case. Okay? So your theta becomes m pi, right? Where m belongs to any integer. Therefore, your option C is correct, not B. That is the mistake what student will do. So, you have understood this problem, right? Let us move for the next one. Tan theta plus sec theta is e to the power x. Therefore, e to the power minus x, which is 1 by e to the power x, is nothing but 1 by tan theta plus sec theta. Now I can do one thing, sec theta minus tan theta. If I multiply both numerator and denominator, so in the denominator it will be sec square theta minus tan square theta, which is nothing but 1. So it is nothing but sec theta minus tan theta, right? So we got tan theta plus sec theta is e to the power x, and sec theta minus tan theta is e to the power minus x. So if we add, we are going to have 2 sec theta is e to the power x plus e to the power minus x. So from here we can say sec theta is e to the power x plus e to the power minus x by 2 implies cos theta is 2 by e to the power x plus e to the power minus x. Therefore, your option D is correct. We have been given 7 cos x plus 5 sin x is 2k plus 1. So dividing both sides with under root 7 square plus 5 square. So we get, which is equals to under root 74. Therefore, 7 by root 74 cos x plus 5 by root 74 sin x is 2k plus 1 by root 74. Okay? Let 7 by root 74 is sin theta. Therefore, 5 root 74 will be cos theta. Therefore, the left hand side of the equation becomes sin theta plus x, which is your 2k plus 1 by under root 74. Clear? Now, we all know that sin theta plus x always lies between minus 1 and 1. Now, the question is, find the number of integral values of k for which the equation this has a solution. Root over of 74 means it's coming to something like 8 point something. Okay? So, your 2k plus 1 by root 74, this value should lie between minus 1 and 1. Now, root over of 74 is 8 point something. It means what? This means that your 2k plus 1 should be less than or equals to root 74. Is it okay? Now let us put, always remember, root over of 74 means it is 8 point something. Now if k is 0, is it satisfying? Yes. If k is 1, yes, it is satisfying, because if k is 1, the value is coming to 3. 3 is very much within minus 8 point something to 8 point something. If k is 2, yes. K is 3, 7, yes. But if I take k as 4, then it becomes what? 4 2s are 8 plus 1, 9. 9 exceeds 8 point something. So 4 will not come into the picture. Or else what you can take? If I take minus 1, it gives you minus 1. Yes, that is accepted. Minus 2, that is minus 3, which is very much lying between minus 8 point something to plus 8 point something. If it is minus 3, then also it is coming to minus 5. Again, it is lying between this range. But if I take minus 4, look at very carefully. Minus 4 gives you what? Minus 8 plus 1, that is minus 7. Yes, that is also coming within, very much within this range. But if I take minus 5, minus 5, in that case 2k plus 1 will give you minus 9, which is not falling between minus root 74 plus root 74. Okay, so minus 5 is not accepted. So how many number of integral values of k are possible for which the equation will have a solution? 1, 2, 3, 4, 5, 6, 7, 8. Okay, therefore option A is correct. Is this clear to all of you? Okay, next problem. Let us say y equals to now if we separate, I'm simply expanding with the formula of tan 2x. Tan x goes off. So we are left with so from here we can get 1 minus tan square x is 4 by y minus 1. From here we can say tan square x is 1 minus 4 by y minus 1, that gives you y minus 1 minus 4 by y minus 1, that gives you y minus 5 by y minus 1. Is it clear? Now, tan square x, as we all know, tan square x is always greater than or equals to 0. It implies y minus 5 by y minus 1 is greater than equals to 0. So, if we put it on a number line, those who are not comfortable with this number line system, I have given the link in the description box. Please check my videos on inequations. So in this case, y will come here. So your answer is from minus infinity, y less than 1 or less than infinity. Is it clear? Now the question is, your y is either less than 5, y is either less than 1 or y is greater than equals to 5. Now again students do mistake. They say that this option they used to choose either less than 1 or greater than 5. This option is not correct. Why I'm telling you, greater than 5 is okay, but at the same time y can take the value 5 also, but that has not been mentioned in option D. So don't choose option D in this case. What you will choose? You will say cannot lie within 1 and 5. Naturally, y cannot take any value between 1 and 5. Therefore, the proper option will be C, not D. Don't get confused with option D. Okay? So option C is correct, where it is cannot lie within 1 and 5. Is it clear to all of you? Okay. In this problem, they have said that sin theta plus cos theta is 2 and find the number of solutions. Sin theta plus cos theta is 2. It is only possible when sin theta is 1 and cos theta is 1. Why? Because we know that sin theta and cos theta always lies between -1 and 1. So the maximum value that sin theta and cos theta can take is 1. But simultaneously, the value of sin theta and cos theta cannot be equals to 1. Is it clear? Therefore, in this equation, we cannot solve, and hence we will write that there is no solution. Is it clear? Since sin theta and cos theta, the maximum value of sin theta and cos theta is 1, so this equation is satisfied only when sin theta is 1 and cos theta is 1. But unfortunately, sin theta and cos theta cannot be equals to 1 simultaneously. Hence, no solution. The given expression can be written as 3 sin 3 pi by 2 minus alpha will give you minus cos alpha. So it will be cos to the power 4 alpha only. Sin to the power 4 3 pi plus alpha. This one will give you minus sin alpha, but since 4 is there in the exponent, therefore it will be sin to the power 4 alpha only. Is it clear? Minus 2. Sin pi by 2 plus alpha will give you cos alpha, so it will be cos to the power 6 alpha, plus sin 5 pi minus alpha, that will give you sin alpha only, but power is 6, so it will be sin to the power 6 alpha. Is it clear? So this can be written as cos square alpha whole square plus sin square alpha whole square, and for the second one it is cos square alpha whole cube plus sin square alpha whole cube. So for the first one we are applying the formula of a square plus b square, and for the second one we are applying the formula of a cube plus b cube. So we are having for the second one sin square alpha plus cos square alpha is 1, so it gives you if I open the brackets, so answer is 1, hence option B is correct. In the triangle ABC, we have been given let us say this is lambda, therefore if I add the corresponding sides, we are going to have that implies a plus b plus c is 18 lambda. Okay. Now if I subtract this equation from this one, we are going to have the value of a, which is nothing but 7 lambda. If we subtract c plus a equals to 12 lambda from this equation, we are going to have the value of b, which is nothing but 6 lambda. And if we subtract a plus b is 13 lambda from this equation, we are going to have c as 5 lambda. Is it clear? Now we have been said to find out the value of cos c. So cos c is nothing but This is the cosine formula. So we are simply putting the values of A, B and C. $84. Let us cancel. So 5/7 is the value of cos C, hence option C is correct. Is it clear? Okay. Now the given expression, I am grouping the terms according to our need. So now applying the formula of sin C plus sin D. Let me take 2 cos 7 degrees common. Now applying the formula of sin C minus sin D here, we are getting now let us simply put the values of sin 18 degree and cos 36 degree. So we are having sin 80 degree is root 5 minus 1 by 4 and cos 36 degree is root 5 plus 1 by 4. So we are having left with cos 7 degree only, hence our option A is correct. In triangle ABC, A cos A equals to B cos B. Let us use the cosine formula of cos A and cos B. So we are getting two goes off, CC goes off. So let me cross multiply. Let us open the brackets. A square B goes off. Let me take every expression in the left hand side. From this 2, if I take C square common, it is A square minus B square left. And in this case, if we apply A square minus B square, because if I put a bracket, it will be A to the power 4 minus B to the power 4, which can be written as, now applying the formula of A square minus B square. So we are having now if I take A square minus B square common, so we are left with is it clear? Now either A square minus B square is 0 implies A is equals to B, but A cannot be equals to B because they have already said that angle A is not equals to angle B. We know that the angles opposite to the equal sides are equal. If A equals to B, then capital A must be equals to capital B, because capital A is the opposite angle of the side A and capital B is the opposite angle of side B. So they cannot be equal since they have said that angle A is not equals to angle B. Therefore, our next option is correct, which is C square minus A square plus B square equals to 0 implies A square equals to C square plus B square. Option A is correct in this case. Is it clear? We have been given so from here we can write So if I divide both sides by so this becomes 0. That implies tan alpha plus beta plus gamma is 0. That implies alpha plus beta plus gamma can be either 0 or pi. Is it clear? Now, we have been given that x is cos alpha plus iota sin alpha. Now, from Euler's rule, you can say this thing as e to the power I alpha. Y is cos beta plus iota sin beta. Again, Euler's form, e to the power I beta. And z is cos gamma plus iota sin gamma. It is e to the power I gamma. Okay? So, xyz is basically e to the power I alpha into e to the power I beta into e to the power I gamma. That gives us e to the power iota alpha plus beta plus gamma, which can also be written as cos okay. Now, we know that alpha plus beta plus gamma can be either 0 or pi. Now, when it is 0, then xyz, the value of xyz will be cos 0 plus iota sin 0. So, that gives you 1. But when alpha plus beta plus gamma is pi, that gives you, which is nothing but your minus 1. Therefore, the value of xyz can be either 1 or minus 1. Hence, option D is correct. Sin x plus sin square x is 1. It is given. So, sin x can be written as 1 minus sin square x. That implies sin x is nothing but cos square x. Okay. Now we have to find out the value of this given expression. Let me take cos to the power 6x common. So we are left with this can also be written as so this is the formula of a plus b whole cube. So that is cos square x plus 1 whole cube. Cos to the power 6x, I can take it inside the bracket, so it will become cos to the power 4x plus cos square x whole cube. We have already proved that cos square x is nothing but sin x. So cos to the power 4x can be replaced by sin square x. Sin square x plus cos square x is 1. So it is 1 cube. Answer is 1. Hence option A is correct. Is it clear? Question number 17. X is 2 sin theta by 1 plus cos theta plus sin theta. Sin theta can be written as 2 sin theta by 2 cos theta by 2. 1 plus cos theta can be written as 2 cos square theta by 2. And sin theta can be written as 2 sin theta by 2 cos theta by 2. So, if I take two cos theta by 2 common, so we are left with cos theta by 2 cos theta by 2 goes off. So we are left with 2 sin theta by 2 by cos theta by 2 plus sin theta by 2. Therefore, your x is nothing but this one. Now we have to find out the value of, I can write this thing as one minus cos theta can be written as 2 sin square theta by 2. Sin theta can be written as 2 sin theta by 2 cos theta by 2. And 1 plus sin theta can be written as cos theta by 2 plus sin theta by 2 whole square. Is it clear? Do you know this? Because, let me do it here. We know that 1 plus sin theta, 1 can be replaced by cos square theta by 2 plus sin square theta by 2. And sin theta can be replaced by 2 sin theta by 2 cos theta by 2. So that gives us cos theta by 2 plus sin theta by 2 whole square. Okay. If this one is minus, this one will be minus and this one will be minus. Is it fine with you? So I have replaced 1 plus sin theta with cos theta by 2 plus sin theta by 2 whole square. Now let me take 2 sin theta by 2 common from the numerator. So we are left with let me cancel one term. So we are left with 2 sin theta by 2 by cos theta by 2 plus sin theta by 2, which is exactly your x. Okay. Hence option C is correct. We have to solve 1 minus cos theta is sin theta by 2. 1 minus cos theta can be written as 2 sin square theta by 2. Let me take it one side and take 2 sin, not 2. Let me take sin theta by 2 after taking in the left hand side common. So we are having is it clear? Let me take 2 sin theta by 2 common again. So either sin square theta by 2 is 0 or 1 minus cos theta by 2 is 0. Okay. Now when sin square theta by 2 is 0, your theta by 2 is n pi, implies theta is 2n pi. Okay. When cos theta by 2 is 1, then theta by 2 is 2m pi, theta is 4m pi. Okay. Now from this equation, you can understand that either this will be 0 or this will be 0. Okay. Now, when theta is 2n pi, observe very carefully, this particular value of theta involves these values also. Yes or no? But this value not necessarily involves this value. Are you getting my point? Let me take an example. Let us say n is 1, 2, 3, 4. Let me put 4 values. So here, when n is 1, theta is coming to 2 pi. When n is 2, theta is coming to 4 pi. When n is 3, theta is coming to 6 pi. When theta is 4, when n is 4, theta is coming to 8 pi. In this case, when m is 1, 2, 3, 4. Let me put those values. So theta comes to what? 4 pi, 8 pi, 12 pi, 16 pi. Observe carefully. All those values, whatever we are getting here, we will get it here. Jaise 4 pi, 8 pi, all those things we got. And we will get 12 pi, 16 pi, everything in this. But we will not get the values like 2 pi in this, from this solution. Okay. Now, so for all values of theta we are getting from this equation, it will satisfy this equation also. Is it clear? Therefore, the required value of theta is nothing but 2n pi. Hence, option B is correct. Is it clear to all of you? Question number 19. They have said that B square equals to C square plus A square. Now, if I draw a right angle triangle, The sum of the squares of two sides is equals to the square of the third side, means it is a right angle triangle, where here B is here, A is here, C is here, because B square is nothing but A square plus C square. This is 90 degree, B is the hypotenuse, A is the perpendicular, and C is the base. Okay? So, let me just give a name. The opposite angle of side A is A, the opposite angle of side B is B, and the opposite angle of side C is C. So, what is your tan A? Look it carefully. What is tan A? Tan A is nothing but A by C. And what about your tan C? Tan C means, with respect to this angle, your tan C will give you C by A. So, tan C is C by A. Therefore, tan A plus tan C will give you what? A by C plus C by A. So, if I take AC LCM, it is A square plus C square. Now, A square plus C square can be replaced by B square. So, it is B square by AC. Is it clear? Therefore, the value of tan A plus tan C is B square by AC. Thus, option D is correct. Is it clear? Okay. Now, we have to find the value of this expression. Apply the formula of sin C minus sin D, which is 2 cos C plus D by 2. Sin C minus D by 2. And in the denominator, cos C plus cos D, 2 cos C plus D by 2. Cos C minus D by 2. Now we have been given that x plus y is not an odd multiple of pi by 2. Okay, x plus y is not an odd multiple of pi by 2 implies cos of x plus y is not equals to 0. Okay, so we can cancel this cos x plus y from numerator and denominator, and we are left with tan x minus y. And we have been given that x minus y is 4n plus 1 pi by 4. That implies tan n pi plus pi by 4. Is it clear? N pi plus pi by 4. Tan n pi plus pi by 4, where n is an integer. Tan n pi plus pi by 4 will give you tan pi by 4, which is nothing but your 1. Hence option C is correct. Is it clear? 21. 1 plus cos theta is k. That implies 2 cos square theta by 2 is k, implies we have to find out sin theta by 2. Cos square theta by 2 is k by 2, implies 1 minus sin square theta by 2 is k by 2. That implies sin square theta by 2 is 1 minus k by 2 equals to 2 minus k by 2. So that implies sin theta by 2 is nothing but under root 2 minus k by 2 plus minus. Okay. But observe carefully, they have said that theta is an acute angle. That is, theta is in the first quadrant. Therefore, theta by 2 is also in the first quadrant. Yes or no? Because, let me just write in this way. Your theta is in the first quadrant. That is why it's an acute angle. Therefore, theta by 2 is what? It lies between 0 and pi by 4. That is, again, it is in the first quadrant. So, in first quadrant, sin theta by 2 will be positive. Okay. Therefore, your sin theta by 2, where theta by 2 is in the first quadrant, it is under root 2 minus k by 2. Hence, option B is correct. Is it clear? Okay. Question number 22. The value of the expression cos 1 degree, cos 2 degree, cos 3 degree, cos 179 degrees. Now you see, in between this expression, there will be cos 90 degree. Tell me yes or no? Now we all know that cos 90 degree, the value of cos 90 degree is 0. So whatever may be the values of this expressions, it doesn't matter, the answer will be always 0. So option D is correct. Question number 23. If del equals to a square minus b minus c whole square, I am applying the formula of a square minus b square. So we are having we all know that 2s is a plus b plus c, where s is the semi-perimeter. Therefore, your del can be written as 2s minus c, and in this case a plus c can be written as 2s minus b. So we are having 2s minus 2c, 2s minus 2b. Now if I take 2 common from each expression, so we are having 4 outside, s minus c, s minus b, okay, where del is the area of that triangle. Therefore 1 by 4 is nothing but s minus c into s minus b divided by del, right? Now we all know from the half angle formula, tan a by 2 can be written as under root s minus b s minus c divided by s into s minus a. Therefore, multiplying numerator and denominator within the root sign with s minus b and s minus c, so we are having getting, and the denominator will be from the Heron's formula, it is del, and that is nothing but your 1 by 4, okay, from this one. It is 1 by 4. Therefore, tan a by 2 is 1 by 4. Now we have to find out the value of tan a. So we are applying the submultiple formula of tan a. We are having, let me just plug the values of tan a by 2, which is 1 by 4. So it is half divided by 15 by 16. So that gives us 8 by 15. Is it clear? Therefore, the value of tan A is 8 by 15. Hence, option D is correct. Question number 24. Cot square theta can be written as cosec square theta minus 1 So let me open the brackets. So we are having let me just go for middle term breaking. Let us take 4 cosec theta common. And let me take 5 common from the second from this expression. That implies 4 cosec theta minus 5, 3 cosec theta minus 4 equals to 0 implies either cosec theta is 5 by 4 or cosec theta is 4 by 3. We have to find out the value of sine theta. Therefore, the value of sine theta is either 4 by 5 or 3 by 4. Is it clear? Hence, option A is correct. Question number 25. Let us just group the given expression according to our need. Sine square 5 degrees, cos square 5 degrees. So we are left with cos to the power 6 5 degrees can be written as cos square 5 degree whole cube minus sine square 5 degree whole cube minus 15 sine square 5 degree cos square 5 degree. Now cos square 5 degree minus sin square 5 degree will give you cos 2 theta, which is nothing but cos 10 degrees. Is it clear? Now I'm applying a cube minus b cube formula over here. So we are having a minus b whole cube plus 3ab into a minus b minus 15 sin square 5 degree cos square 5 degrees and cos 10 degrees there. Again, this can be written as cos 10 degree, that is cos cube 10 degree over here, plus this one is again cos 10 degrees, so it gives you 3 cos square 5 degrees sin square 5 degrees with cos 10 degrees minus 15. Now let me take cos 10 degree common. So we are left with this can also be written as, this part can also be written as 3 into 2 sin 5 degree cos 5 degree whole square. This is 2 sin a cos a, so sin 2a, that gives you sin square 10 degrees. Sin square 10 degree can be written as let me just open the brackets. If I take cos 10 degree inside, so we are having four cos cube theta minus 3 cos theta gives you cos 3 theta, so it is cos 30 degrees. And the value of cos 30 degree is root 3 by 2. Hence, option B is correct. Is it clear to all of you? Okay, that's all for set 1.